Assalamualaikum, I am Muhammad Akmal and I'm going to show a simulation of Lab 5, which is electromagnetic wave. First, we are going to do fixed end. For low damping and high tension, we can see that the wave move fast and the amplitude is high. The wave reflect with inversion at the fixed end. A clear standing wave is formed with fewer knots and a longer wavelength. For high damping and low tension, it shows the wave move slowly and the amplitude become low quickly. The reflected wave is weak and the standing wave disappears after a short time. Next, we go for loose end. For low damping and high tension, we can see that the wave move fast and the amplitude is high. The wave reflect without inversion at the loose end, and a clear standing wave is formed with fewer knots and a longer wavelength. For high damping and low tension, we can see the wave move slowly and the amplitude become low quickly. The reflected wave is weak and the standing wave disappears quickly. For no end, low damping and high tension, the wave move fast and the amplitude remain high, and the wave travel continuously without reflection. And for high damping and low tension, we can see the wave move slowly and the amplitude become low quickly, and the wave dies out after short distance. So for no end, standing wave and knots are not formed. This is because the wave does not reflect back along the string. Without reflection, there is no interference between the incoming and reflected wave, so knots and anti-knots cannot be produced.
Name is Afi Amzar. So next I'm going to simulate the wave when we set the amplitude to the high, frequency to the low, damping to the low, and tension to the low. The simulation is set to the oscillate on and no end condition. As we can see, the wave is continuously generated by the oscillator and does not reflect back at the end of the strings. Instead, the wave travels forward and leaves the system. With amplitude placed to the maximum, it produces a taller crest, meaning the wave carries more energy. The low frequency results a fewer wave per unit time and longer wavelength as the wave stretch out. The motion is slow and smooth. With low damping, the wave does not lose much energy, so it continues propagating smoothly without fading quickly. Low tension causes the wave to travel more slowly along the strings, make the motion easier to follow visually. As long as the oscillator remain on, new waves are constantly produced, making the wave motion appear indefinite and continuous. Lastly, I'm going to simulate the standing wave. we set the condition to the fixed end first. Then we set the amplitude to the 0.6, the damping to the low, and tension to the high. Then we set the frequency to the lowest, the low. So as we can see, the string form a one anti-knot and knot and two knots at the both ends. So this wave can be calculated by F equal to 2L, which the L is the string length. We call this wave first harmonic. So next we change the frequency to a little bit higher. We can see it produce 2 anti-knot and 3 knots. So this is called the second harmonic form. This wave can be calculated by F equal to V over L, which V is the wave speed and L is the string length. So next, if we change the frequency to a little bit higher, then we can observe that the wave is a third harmonic. It produces 3 anti-knot and 4 knots. The frequency is a little bit higher than the second harmonic and is calculated by F equal to 3V over 2L, which V is the wave speed and L is the string length. So in conclusion, this lab show that how a wave move depends on the string's tension, damping, and its end. We found that high tension make wave move faster, while high damping make them disappear quickly by losing energy. Low damping allows wave to travel much further and stay visible longer. Finally, by changing the frequency, we can create the standing wave called harmonic, which have specific pattern of knot and anti-knot. This experiment helped us understand the basic properties and behavior of the wave in a different situation. So that's all from us. Thank you.